All right, it is loud. Wow, cool. This is the time of day where everyone's had lunch and they're snoozing off. The lightning talks reinvigorated everyone, but I do have a backup plan. I have prizes to keep you entertained and awake and paying attention. These are the prizes. I'll tell you what they are in a little bit, but obviously from poetry. Right, so the talk's title is Tomorrow's UI Architecture, but what's more important is the little man. I absolutely love Lego. In fact, this talk was actually just an excuse to go and buy Lego. I have prizes. But sadly, that one didn't fit in my suitcase, so I had to keep it for myself. All right, so we've got a miniature Millennium Falcon and a Han Solo being frozen in carbonite. The title, or the theme of my next talk next year will be Star Wars. So I almost didn't bring any prizes today because they didn't fit in my bag, but I found a poetry bag. So, this conference has been great so far. We've had some amazing speakers. I've learned many things. We saw today that Ruby has blocks just like Lego. See, it's red as well for evil. We learned about rockets and how they fly. We learned about church numerals. We went through the land of Mongo, learned what it feels like. Learned about chatbots, also about Alexa. We learned about diversity, and we were reminded that that diversity is being invited to the party, but inclusion is being asked to dance. Cool, and we've convinced our employers that we're actually learning something. And then I'm going to end off with my little, comedy sketch with the brain, because what's great about coming at the end of a conference is you tend to maybe overlap with some of the previous speakers. So about a third of my talk was given yesterday, and another third was given this morning. But I'll refer to Sohoi's talk about brain and making coding brain friendly, right? So, complexity. That's where we'll start our journey off today. Humans quite suck at complexity, but we're very good at pattern matching, and that's why the robots are getting us to teach them to recognize oranges. Also, humans are pretty bad at scale. Actually, we're really good at logarithmic scale, because it turns out back when we were developing, logarithmic scale fitted the use cases we had. Knowing the difference between 1 and 3 buck in the felt is good, but knowing the difference between 100 and 200 really didn't matter, because there's a bunch, right? So we're okay at logarithmic scale. But after that, it gets a bit confusing. We're pretty bad at linear, actually. This is why software developers suck at estimations. And when you get to exponential, we'd rather go eat donuts. The classic case is the chessboard, where you double the amount of money on each chessboard, and you can't believe how rich you get. Cool. So my first experience coding was at school, and it was UI development. I skipped right over console development to terminal applications, went straight into the UI. And this actually was less complex than console applications, because all I really needed to care about, this is an on-click handler in .NET, if you don't recognize it. I started with Delphi, similar thing. All I really had to care about was the little bit of code between the start and the end of that method. Right? The runtime says something's happened, give you some information, you do a bunch of stuff, and you set some values. Right? I never really had to think about background, because at this stage, I was quite happy blocking the UI while we waited for something. And it was valuable for the customers that I wrote for, slow, but valuable. How's this? Cool. But the complexity level was okay. Right. After that, I got into web development with MVC and Rails. And again, I could frame it in this mind where I could keep a linear flow of actions. It's actually even simpler, right? The request comes in, you do some stuff, and you return something. There wasn't even really much side effects until you get to caching. But again, back here, no caching. Quite simple. Request in, generate a view, and move on. And that complexity level's pretty good. And then I was forced to do iOS development with real MVC. And because of the device limitations, you kind of want to keep the UI thread flowing. And iOS is really good about user experience, right? So
right off the bat, they teach you to do any long-running tasks in a background thread. And we didn't have like a separate system, like a database to do the work for us, so you offload it to a background thread and come back onto the UI thread to update the UI. This complexity level, and the bugs started creeping in. And then I built a single-page application. Build a single-page application, they said. It'll be fun, they said. I mean, it's in the name. So, we'll carry on from where we actually started doing well at single-page applications. The first one that actually launched and was successful that I built was around the time React had just come out. It was starting to take over the market. And Facebook had just released Flux as a mental model for doing state management. And it looks quite simple here. An action came in, the dispatcher would dispatch an action to a store who would act on it and update the state. And if you're familiar with React, that would flush the UI. And we learned about React. This is part of the overlap. And then it would re-render, right? And this is fine, and we thought, okay, this works well for us, we'll carry on. But it did end up with a totally new interaction diagram because our stores were quite well modularized and focused on one thing, but there were dependencies between the stores. And when we started writing this, Facebook didn't release like their spec and how to do this, so we ended up with situations like this, where an action would come in, be dispatched to the first store, start processing, a second action would come in, the store one would then hand over control to the second store, and all in between the UI was being updated. That's the complexity level. Bugs everywhere, house burning down, and we couldn't quite figure out what was going on, but everything was fine because we were in production. Right. So, why did that get so complicated? So yesterday we learned about working memory. I learned about it as visual working memory. And it turns out that humans can only really keep like 3 or 4 things, concepts in their brain at a time, right? We have got 2 thinking systems. There's a book called Thinking Fast and Thinking Slow that goes into detail nicely. We've got system 1, which is really good at pattern matching and reacting quickly. And system 2, which actually does the hard work and logically reasons through things. And system 2 really has a small desk to keep things on, and it can only look at 3 things or 4 things at a time. Turns out it doesn't matter how complicated those things are, because we wrap them up and we like picture them as a Lego block, and then we can carry on. But if you go back to this diagram, there's just too many little blocks on my desk to keep track of. They're not nicely wrapped up, and everything's going on, and you tend to like forget about those that fall off the side, because you can only focus on the 4 things on your desk at the moment. So, visual working memory, it's important to keep in mind when you're thinking about software complexity. The next one is nonlinear reasoning. Right? Humans, as far as I know, only move forward in time. We think that way too. But when you look at a diagram like this, it feels like time travel. So as soon as you stop being able to reason about things linearly, we struggle. And you have to engage system 2, and you're thinking about it, and then you can only think about 3 things at once. And this leads to like a lack of tracking of dependencies and things that are coming downstream, or how I got influenced. And all of this really just makes software feel too complicated for me, and I thought about going to farm. So the side effect of this is when you're keeping all these things in your brain, if you get disrupted, these things like disappear, and you have to start building your mental castle again. I don't know if you've seen this, it's great. I show it to my wife all the time. But it actually feels more like this to me. I've built my mental castle, and I love these guys' reactions. There's another one. Right, so what we're actually going to talk about today is the war against complexity, and 3 techniques that will change your life forever. Right, first technique. Let's think in simple, small components with clear boundaries, right? There's a great talk by Gary Bernhardt of Destroy All Software. It goes into this concept of boundaries, right? And treating data as a boundary. So if you keep your components really small and you only have to think about 1 or 2 things inside them at a time, that's great. Then if it falls over, you only need to think of those 2 things. But small, simple components are what my mind can process. And I'm assuming that if we're coding for the lowest common denominator, that you're going for me. So keep your components small and simple. An example of this is pure functions. Pure functions are my favorite thing in the world. Like, you put something in and something comes out. There's no side effects and it's linear. It takes me back to the days when I completely ignored everything that was outside of my method body. there's this concept called functional core imperative shell, right? It's also introduced in that talk. So what this means is we try and keep as much of our system as possible in pure functions, in pure, simple, small components that don't have side effects, that are easy to reason about, and then we put all the horrible side effecty stuff in this layer around the outside. I'm going to talk about the elephant in the room at the moment, right? This is a Rails conference, and a Ruby conference, basically a Rails conference. But the thing that got me going down this route was when I left pure Rails development and started building spaghetti, right? So Redux. This is the only bit of in-depth JavaScript things I'm going to talk about right now. Redux changed the way I think about applications. They pretty much enforce you to get the functional core imperative shell right. Everything in Redux is written in pure functions. You have a view of the world, and an action comes in, and you create a new world and carry on, right? This idea of pipelining pure functions together with actions coming through, it changed my view of software and how I build software, and I don't think I will ever be able to think about building software without functions again, and pure functions. But the other thing Redux is, it's an event bus. And if you've been using Redux for a while, you don't realize this, but you use Redux to communicate between different components on your systems through this interface that is an event bus that's actions, right? That'll get more important later on, but Redux is two things. It's a purely functional way to view software, and it's also an event bus to communicate through different components. And that's the end of Redux for right now. Right. The last principle I want to talk about is it's better in a sentence, to be honest. The statements within a function should all be written at the same level of abstraction, and then a little bit at the bottom, which should be one level below the operation described by the name of the function. What does this mean, right? So let's take a look of a block of code that isn't written like that. So we've got on line, where's the laser? Yes. Got on line 1, we're doing a database call through Active Record. We're going to go find a bunch of items. On line 2, we're going to, I'm guessing, extract the names from the items and store them in a variable. Then we're going to create a new empty array, and then for each name in the list, we're going to do something to that name, put it in the array, and then we're going to render a view at the end. So if you look at this, there's a whole lot of different levels of abstraction here, right? I like to think of this when I'm looking at code as the what and the how. Let's look at a slide that has correct levels or similar levels of abstraction. When you're looking at a process flow, you really want to know what is happening. You don't really care about the how at that moment, right? And we covered this yesterday. We had great examples of refactoring into brain-friendly code, and I think this is more brain-friendly code. Right now, all we care about is what's happening. We don't care about how it's happening. If you were working in the find items function, then you care about how that's happening, but nothing else in the world. This allows you to keep the items in your visual working memory at a minimum. This is why I like this code, and this is why I think it's brain-friendly. And this is why I think this principle is incredibly important, and it's quite hard to put into words, other than to say, like, keep your functions like Lego blocks, that you can work with them, right? It all comes down to a firebreak against complexity. So if we go back to the dominoes falling over, if I only had 3 dominoes and they fell over, I'm not going to be that sad. And I don't really care about any dominoes apart from the 3 that I'm working with right now. And then when I'm done with them, I put them in a packet, and then I work with 3 packets. If they fall over, it's fine. Right? But the moment you start having this interweave dependency tree of dominoes that reaches the ceiling, if one part falls over, everything falls over, and you have to start building that mental model again. So this is why visual working memory is incredibly important for programmers. Right. The last principle that I'll go into is the single responsibility principle, right? It's the S in solid, and yes, it still matters today, even if you're doing functional programming. Right, the single responsibility principle says a class should have only one reason to change. But if you're writing functions, you don't have classes. That doesn't mean we throw it away, it just means maybe we reinterpret it. I like to interpret the single responsibility principle as what changes together should live together, right? It's kind of the inversion of the top one. Why is this? Again, for me, it's co-location of facts in my brain. So what implications does this have to modern UI development? JSX is a great example of keeping things that change together. When I first saw JSX, I thought it was crazy. I pushed back against it, right? I thought mixing JavaScript and HTML is stupid. We've got views for a reason. And I wrote the first application without it, and it sucked. And then I tried it because I thought, well, what's the worst could happen? And my life was changed. A more modern take on it is CSS in JS, right? A lot of people feel very uncomfortable with co-locating their styles inside the JavaScript file along with the HTML and logic. And this is completely fair. But I'm saying the uncomfortableness that people feel with it is more for a lack of tooling and experience. CSS has been with us for a long time, and we've got good tools to work with it as CSS. This is brand new, right? This has been around for like 18 months, 24 months at most. And people are very uncomfortable with it. But I predict this way of building UIs is going to take over completely. Why? Well, for one, the fact that we're using CSS is an implementation detail about the browser. But when you start building mobile applications, CSS goes out the window. And you saw earlier today that React Native for web is a library that allows you to build web applications using the React Native application components you've built. UIs are actually UIs, and where they get rendered is an implementation detail. CSS is an implementation detail, and the sooner we can move to a level above that, the faster we'll be able to reuse UIs across different applications. And the moment we get that right, VR is going to come in and change everything. Right, so we used to split our code up by the type of code it is, right? Even in Rails or in other applications, you have views, you have controllers, you have models. That's the type of component it is, right? And we can think either in horizontal concerns that we'll split or in vertical concerns. And when you get to UI level, and it's a pleasant fact, but most of the time the really heavy crunching has been done in the back end, right? All you really want to do is show an interaction of a specific concept. And sure, if you're factoring your code wrong, you're putting your complex logic inside your UI. And I still don't think that's wise. But by the time you've factored out your complex code, it's either running on a server or on a service. All you're dealing with is showing a concept to a user. When you need to change that concept, chances are you might need to touch the styling and the display logic. These things live together now, and you can open one file. If you go look at the Git diffs of code written like this, it is beautiful. It is beautiful because if you're working on a concept, all the concepts are co-located and you change them together. All right, I've actually been setting the stage for the little bit of the next talk, right? So I've said I've built mobile applications and I've built web applications, and I've started to see a lot of similarities between the two and actually draw a lot more inspiration from mobile interfaces than to inspire how to build web interfaces. So, Storytime. After I'd built my spaghetti, I got hired by a company that had enough time and money to put a little bit of research into building a new modern front-end platform. By the time we landed there, their back-end platform was pretty much sorted. They had factored out most of their core services into microservices, and they were like, cool, we need some JS guys to come sort out the front-end. So, build a modern platform that scales development horizontally. The most important thing for them was that we could really quickly roll out the UI. We could spin up multiple teams in parallel, and they should be able to work, right? They also said it needs to be easy to learn and get going quickly, because the old system took roughly 3 months to get a developer productive. And that doesn't mean 3 months to get going, but it does mean the system was so complicated and glued together that by the time you actually understood it all, 3 months had passed. And then it has to be fast and traceable, because we get lost in our current monolith. We don't know what is slow. But also build a single-page application. That had been decided before we got there. I was like, okay, cool, we'll try. Right. We started with Ember and moved to React, but that is a different talk. This is an illustration of what we started out with, right? At the front, we've got a client, and we've got different features that the client's working on. And then we implemented a gateway layer to speak to the microservices in the back end. Each gateway layer would know which microservices are required to call for each feature. I actually want to get to a different slide. At this stage, I was wondering, when I heard the talk on GraphQL this morning, whether we'd chosen to walk to Mordor versus the eagles of the GraphQL. Right, so when you're working with state on the client side, there's a couple of choices you can make. Maybe up to a year ago, Twitter released how they were building their UI applications, and they were showing how beautifully normalized their store on the client side was. Like, they had a collection of tweets, they had a collection of users and profiles, and that is definitely the way like we tend to think about data if you've worked with a relational database. Normalized in one place, so you have one source of truth, and if you update it, it changes everywhere. We've got some trade-offs here, right? So A normalized store is fast sometimes. It's fast if it's already in the store on the client. If you still have to make a request, it's not. And it's fast if the data in the normalized store is in the shape that you need it for your UI, but if you have to make complicated transformations, it's not. So I gave like half a point to each side there. It's consistent, but with a red dot, which we'll dig into a bit later, and it's definitely coupled, right? Whereas a denormalized store is simple. It's fast because the data is always in the shape you need it in, but it's not necessarily consistent. So why do I have a red dot next to consistent and coupled? I'll talk about coupling first. If you've got a normalized store and multiple people using it, everybody is dependent on that store, and it becomes quite difficult to change. If you have one representation of customer and everybody's using it, if you need to change the shape of it, you first need to consult everybody who's using it. And this is on the UI level. This is not on the domain level, right? Everybody has a different view of customer. If you're trying to view the customer profile, you care about everything about the customer. If you're trying to view his account, you literally just want the customer's name. And caching. A normalized store inherently involves caching, because the whole idea of a normalized store on the client is if I fetch the data, then I go to another page, that data should already be there, and I don't need to refetch it. So refetching data is a big no-no with a normalized store, but the flip side is, how do you deal with stale data? When do you refresh it? And for a lot of applications, this is not important, but we found that users were keeping our tabs open for like 4 or 5 days at a time. So we'd have to have come up with a way to flush this cache manually. With a denormalized store, each page fetches their own data, and we actually went as far as saying, look, just fetch the data every time you load your page. Because I don't know if you've run into this problem, but if you are caching data client-side and you need to update it, you either deal with, when you go to a new page, a spinner, or you fetch in the background and you've got cache data and then the new data pops in, or you just deal with stale data, right? And when you're making a trade-off between development speed and complexity and runtime speed, a denormalized store that you fetch every time that you go to a page is super. It's super simple, it's always fresh, and there is a performance concern, but we reasoned that we can sort that out later. And if you're interested in that, I'll tell you about that later. All right, so let's have a look at what a normalized store looked like on the client side. We had several different features that the client was fetching, and transactions and performance both depended on their account object. Transactions then had their own transactions, and performance had a bunch of performance data. This gets complicated when you have team A working on transactions and team B working on performance, and they keep running into each other on accounts. Again, I must, at this stage, admit that we were wondering whether we should have just gone with GraphQL. But what we realized is that the gateway layer and the transactions layer on the client were actually closely related. And I mentioned earlier that things that change together should live together. So our gateway layer was a Node server, and our client happened to be a React application. But this functionality was actually so closely related that whenever we were working on the transactions feature, we ended up working on the gateway and the client. So that's what we did. We split the application up into 3 different features, and the teams would work on the features, and they wouldn't share any code on the client side. We actually went a little bit further and looked at the actual features inside of transactions, and you'll see we had a list transactions feature, create transaction, and edit transactions. And we found out that the gateway for those were also intimately related. Let's have a look at what happens when you start splitting your store up like that. At the top there, you've got all the information that edit transactions need and each of the other features. What's great about this is you only fetch the data you need, it's in the shape you need it, you don't need any more processing, and you don't impact teams around you when you change it. But also that kind of looks resourceful, right? These kind of look like the routes we used to have back on the server. And this is when my brain started tingling. I'm like, whoa, we're going back to MVC. The complexity level is going to be great again. Hold that thought. It also kind of looks like Lego if you put dots on it. All right. So you saw us breaking up the application down first into features and then into actual interactions. This felt very much to me like microservices, right? The microservice movement is to wrap around features into small services that can move independently and don't have internested dependencies on each other. So I started wondering, is there like a microservices front end? It turns out there are. It's called micro front ends. And there's a site called micro front ends. And when I found this site, I was like, we're onto something. We're onto something, because at least one other person believed in this enough to make this diagram. But the interesting thing is that their problem was exactly what we had. We had a microservices backend, a monolithic front end that we were breaking up, and an aggregation layer. Right? This seems to be the trend when you start working in feature teams with amounts of people, and you want autonomous teams that can move quickly. The other thing we started looking into was composing UI at the edge, like the cool guys. And I don't think you can see, maybe you can. Like, I attended ScaleConf last year, and it was right about the time we were thinking about this architecture. And two different people were speaking about how they composed their UI architecture at the edge. Right? They didn't necessarily have a SPA, but they would have their feature teams build the UI up in different teams and in different locations, and then they'd have an edge server, which would call out to the microservices and then stitch it together and send the HTML out down to the server. It also dawned on me that a visual interface is just one interface to the information that lives inside that domain. Right, an API that serves JSON versus a visual interface that's for people, but it's the same information, right? So we started looking at composing our UI on the edge, having the services render their own UI, and then just sticking them together in one application. And then they said, can we do SSR, server-side rendering? Build a single-page application, they said. So at this stage, one of my colleagues in a different team said, you do realize you've just gone full circle, right? It dawned on me that we built a single-page application, and we're just going to render it on the server. That's what I felt like doing. But to be fair, there is some reasoning in this, right? So server-side rendering has undeniable benefits for the user. If done right, it can reduce the time to first render and to first interaction. But the component-based UI model and after the first render have advantages too. So I'm a big fan of server-side rendering when it's applicable for single-page applications. But there's a lot of trade-offs involved, including performance. And if you've got lots of people and lots of servers, then you should be doing it. And somewhere in the middle, you shouldn't. But here's the secret to server-side rendering. And this is something we knew back in the day before we started building SPA applications. You need the data before you can render the view, right? And if you're used to building component applications, and we saw an example of components today, that you want your components to take care of their own concerns. But if you need to serve, a second example, right? So we've got a tree of components, each rendering themselves. But you don't know whether this component's going to be rendered until this component's rendered. You don't know whether this component's going to be rendered until this component's rendered. And each of those has a I/O call to go fetch their data. It took us a long time to realize that why there was so much friction around server-side rendering was that we were loading data in too many places. We had all these little pieces that all went and fetched their own data, but we didn't know whether they were going to be necessary until we built the whole tree, right? It also leads to like nonlinear reasoning. You have all these temporal loading of data somewhere in the component tree, and that adds to complexity. Let's take a step back and go to pure functions, which makes me happy and calm. It turns out that to run a pure function, you need the inputs before you run it, right? So we started thinking of these features as, if I'm going to server-side render something, I need to get all its data. Right, it's time to introduce the magic word, scenes. What is a scene? The official definition I found is, a scene is a sequence of continuous action in a play, film, opera, or book, and now applications. Turns out scenes have been around in mobile applications for a while, and the mobile guys are way ahead of us. So let's take a look at list transactions, right? What is a sequence of continuous action? If we take it from the request that we first make to our server, we then go fetch the data to server-side render the list transactions page, we render the scene, and we return a response. This is like beautifully linear, right? So the interesting thing about client-side applications is most of them represent a flow like this with some magic afterwards. It's very seldom that you have constant action on one single concept. So applications where this doesn't hold true is like Photoshop, where you'll be working a lot of time on editing one photo. But most data munching applications that we build in line-up business actually involve process flows that have a start and an end and finish, right? And the interaction you want to sprinkle is part of that process flow. So if we take again a look at list of transactions and we look at this approach to it, we get a request for listing transactions. We fetch the data, we render the scene, we return the response. And then you have all the nice interactivity of like client-side validations baked in there, but that doesn't need to be rendered on the server. What happens if a user does navigate on the server after the first page is loaded? An event is dispatched, it updates the store, render the scene response. This linear flow is beautiful to me. And this is what Redux gave me, right? And then we navigate to another URL, but we don't actually need to go to the server to render it. We just need to fetch the same data that's identified by the URL, update the store, render the scene. It turns out that the URL is like the identifier for the data we need for this scene and this feature. And whether we need to render it on the server or not, this URL identifies the data we need to start this process. So, here's some rules around if you want to structure your application using scenes. The initial data requirements of a scene to render it need to be identifiable by the URL. Whether this is in a browser or in a mobile application, you need to be able to say, this is my input, go fetch me the data, and I'll render you the scene. It must be cohesive and represent a single feature or workflow. When you start doing something else, you move to a different scene, and you get the data for that scene. And it turns out people, users, think better like this as well. It should not be coupled to other scenes, right? There's actually a significant amount of literature around structuring your applications around scenes and around features like this. But what it boils down to is keeping the amount of concepts in visual memory low for developers and low for users. All right. This has been purely theoretical. I don't have a Ruby gem for you. The thing is, this is a conceptual pattern, right? It's theoretical. And it can be applied in various different UIs and different platforms. From mobile to all the different SPA frameworks, it can be applied for Rails. The important thing is that we don't forget the lessons we've learned from the previous generations of building UIs, right? Turns out most users do think in processes, and most processes have a start and an end. So I'd like to go over those principles again, because the principles actually apply more generally. This is just the selection that we've chosen for scenes, right? Small, simple components. This turns out to be true for functions, but it also turns out to be true for structuring your applications. Rather than having a user profiles application that you think about listing transactions or listing the user profile. And it turns out that you get value from these features as well. And there's a fantastic book called The Phoenix Project, and one of the principles they speak about there is that the time for return on investment for software projects needs to be fast, right? Otherwise, you spend a year building something and the business generates no benefit from it. And in manufacturing, this has been the case, and they've known it for a long time, that you cannot have a process that takes a year before you can verify whether it works. But in software, we seem to be completely okay with that. So breaking down your applications and on every level to small, simple components that you can verify quickly holds true for functions, which you can unit test, and applications and workflows. There is value in being able to see all the users in your system before being able to add them and remove them. Next, keep functions inside a method body at a similar level of abstraction. This allows you to work in concepts rather than in implementation details, or when you need to slip into implementation mode, only that, not the process. And finally, things that live together change together, right? And it helps you, again, to keep your concepts focused in working memory and your Git diffs beautiful. So what about in Ruby, right? There's a couple of other frameworks that do this quite well, and Trailblazers is one of them I can highly recommend. When I started seeing the folder structure, a Trailblazer repo looks structured around concepts and operations. And you start thinking in the same flow. I was like, wow, wish I found this before I started doing that SPA. And then React on Rails, right? The first time I saw React on Rails and I read the Office End blog post, how they were redoing their UI with React on Rails, I thought they were mad. I thought a SPA is a SPA. You have one code base and it works together and you never need to go refresh once you've done the first page. But it turns out those refreshes aren't as expensive as trying to keep the whole thing in your head. And React on Rails works like this, right? There's a code snippet at the bottom. You get a request in with some details, you go fetch the data, you render the scene, you have the response. That's the model we're working with. In the view, you literally pass through the React component you want to render and the data. You keep the MVC mindset of fetch data, render view, and now you have React on the client side. And you can sprinkle it with all the beautiful, live, dynamic interaction you want. But it kind of forces you to keep your features separate and not to interlink them. So, OfferZen guys, good call on that. It turns out that React on Rails was Eagles and not walking to Mordor. So I will just give you all a word of advice. I don't actually know what I'm doing. And every project is different. And when you're standing there with your blank canvas, maybe this will help you. I will also have a caveat that most of the patterns we thought out there were best applied to bigger teams. But the mental benefits of keeping your components small and focused and thinking in workflows are applicable whether or not you're working in teams of 100 or 2. And finally, the one message I want you to take away is build more Lego, even if it's just. Cool. Thank you, everyone.